Hello everybody, my name is Dr. Neeraj. I'm from Department of Management, Volega University. I'm working there as Associate Professor. Now, today I'm bringing a short video on RStudio, basically correlation matrix. Many times we need correlation matrix and how we can make a correlation matrix in R. So this is my RStudio. And now straight away we will import a file. So we can go here, import. It is a CSV file, so read our text file. We click this, then I will browse this, go to the folder. So my folder is R, and let me find the CSV file which I want to import. See, this is CSV file. So salary MLR1 is my file. I will click it, I will click open. Even there is a command again and again. I don't want to open this box. I can select all, that is Control A and Control C. I can copy this and put it in my programming script. Then I don't have to open this again and again. So this is our file which has come over here, and I can straight away say import. The command which I have copied, I can put it here so that I don't have to do this again and again. So it has come here, and this is my file. Now suppose I want to have a correlation matrix for these variables: experience, age, leadership, and salary. What is the correlation between these variables? I want to have a matrix of correlation. So how I can do that? Now you can see that there is one more column which is ID. So I don't want this particular column to be there because it will create confusion when I am making a correlation matrix. So what I will do is I will remove the first column, and then we can go ahead with the command for correlation. So what should I do now to remove this? Let us go to the program. First I will convert this into, this is my environment, and this is the file. It is numeric. I'm just checking the, yeah, it's numeric, so that's good. So for the sake of safety, what I will do is I will just write, I will convert this into data frame, a new data frame, say df1. So I will put the command data. Okay, data frame, and our file name is salary. There are various types, like list is there, matrix is there. So for safety you can do this one command so that it is a, we are sure that it is a data frame. And just press this, and df1 has come. Okay, now what I want is, I don't want the first column. So what I can do is, because now it is, I'm sure it is a data frame, what I can do is I can remove the first column by this particular command. So say df2, the new file which I'm making, in which the first row will not be there, first column, I'm sorry, first column will not be there because it is an ID. So what I do is, now I write df1 and make this particular bracket over here. Now in data frame, if I put comma here, this first space is row and second is column. So are we talking about row or column? We're talking about the first column, nothing to do with row. So I don't touch this particular, I do not touch this particular part because this is row, but I am interested in column. So column number 1 I want to reduce or I want to delete. I will write minus combine. Minus means delete. Combine means anything in this will be deleted. So mine is only 1, so I will just put 1 first column. Because row is blank, this is considered as column by R. Now I'll press enter and df2 has been made. I will click double click df2. Now you can see that ID is not there. It will create unnecessary confusion in correlation matrix, so I removed it. Now I am going to use this df2. I'm basically, making new data frames. I'm not touching my salary MLR1. It is original file which is here. You can see here. If I click this, you can see ID is still there. This is the original file. I have not touched it. I have not mutated this. I am just changing things and making it into new files. But original file is intact. That is important for us. Something happens, we can come back to this original file. So now we are in df2 and df2 is what? Double click. It is a file without ID and our variables are there, what we want. Now I will write a simple command which is correlation, COR. And what is COR? It is in stats. COR says that, if you can see here, it is Pearson's product moment correlation coefficient. So this is what I want. So I will just click this. And what is the name of the file? df2 is what we want. And then I will increase the size of this particular window, remove all this and press enter. So our correlation matrix is here. If you can see this 1 1 1, this is perfect correlation because it is between itself. Experience and experience are perfectly correlated, positive 1. Age and age is perfectly correlated 1. Value is from -1 to +1. Plus is positive correlation and minus is negative correlation. Now for example, age is highly correlated with experience. You can see this. This is experience line. This is age line. Intersection is 0.93. So 93% correlation between age and experience, which is highly correlated. But if I see leadership and experience, it is not so highly correlated. It is 23 only, 23% correlation between leadership and experience. Because maybe because may not be everyone who is very experienced is not a leader, by the way. So this could be reason, and there's basically less correlation. And salary and experience again is 0.41, that is 41% correlation between salary and experience. So this is a triangle basically. If you see this one, it is going down. This is after this line 1, this is a repetition. So this is a correlation matrix. Okay, and one more thing, I have found one good article on correlation which I will put it in the comments or description. This particular article I will put it so that you can refer also. It is very nicely showing things. Like for example, this is strong positive correlation, weak positive correlation. Line of it is this. If it is close, it is strong. If it is scattered, it is weak. Basic idea is this. Now here also it talks about, R is equal to 1 is perfect. More than 1 it cannot be. perfect positive, and -1 is perfect negative. So what is 0 then? No correlation. This is 0. No correlation. What is 1? This is 1. Positive correlation. If one variable is increasing here, the another variable is also increasing positively. What is negative correlation then? This is -1. After 0, this is negative. See, you see the slope after once on the left side, one side is this side. The slope is, if you come here, it is making like this up. Here after 0, if you see, if you increase, it is going down. Here it is increasing, here it is going down. That means it is negative. Negative correlation means one is increasing, another will decrease. So negative is like that. If this is increasing, the other is decreasing. So that is what it is. -1 is perfectly negative correlation. So this is what it is, and these are the criterias which can decide. If you see the coefficient of R, like for example, again we'll go back to our R. Now suppose I want to see, is leadership and experience, what kind of correlation is there? Is it strong, weak, or what it is? First of all, it is positive. We can see here it's not negative. That means leadership and experience are going in the same direction, in a positive direction. Positive it is. In one direction only it will go, not opposite. If it is negative, one will go high, another will go down. So obviously, please don't confuse this with impact. Impact is shown by a regression. This is correlation. So correlation is not showing a direction. It is just relationship only. But if you do regression, it will show direction, impact. Now causal relationship is regression, but this is not causal. So in this relationship, like suppose 0.23, so what should I conclude? So I can see this particular article. What is 0.23? Where is 0.23 coming? Is it positive or negative? So it is positive. So I have to see up, not below. Below is all negative. Above 0 is positive. Now 0.23 is where R is less than 0.4 and greater than 0. This one. Weak positive linear correlation, we can say this. So this is very good for interpretation. This is good for visualization. So this is a good article. I will put it in the comments or in the description so that you can view it. So let me copy this. Now, one second. So this is a very good way of, very easy and simple way of making the matrix. So this matrix can be used for our research papers or for making any analysis. You can easily use it, and it's very simple. Only you have to write COR and the name of the database or name of the data frame. So that is very simple, and with one particular small line, you can definitely get this particular thing. Suppose I don't do all these things. I only import to show you how simple it is. I make it into comments. Everything is comment except this. So let us see if this thing works or not. These three lines will not be activated. Suppose I just read, even this line is not required actually. If I have if I have used this particular import data set, I don't need this also. So let me put hash, just comment. So after I do import data set, my database has come, which is salary MLR1. Yes, and directly I will put salary MLR1. Nothing I have done, only I have imported database import data set, and my salary has come. That's all. These steps are not required. Nothing is required. These steps are required if there is a problem in the data frame. Like mean it is a matrix, it is a list or something. It may show error. It may not also. So I have just taken this particular file, imported this particular file, and first thing I just write cor salary.mlr1, that is the file name, and just say control enter, and things have come. Same thing has come. Let me make it big so that you understand. Again, same thing has come only by one line. COR only you have to write, and the name of the data file name, that is salary MLR1, which we imported, and just write COR and the name of the file, and the correlation matrix is there. So simple and easy to use. Basically, R is a very complex calculator, you can say. Like for example, I will tell you one more thing. 5 into, say I want to do 5 multiply by 6. Again I enter, it comes 30. It's like a big complex calculator or super calculator. So it is everything it is doing easily. Square root, under root, everything you can do. Even you can make your own functions. So this is all about for today, and I will continue to teach you about other aspects of R. Thank you very much for your time.